In this session, we're going to be talking about a univariate test that uses the chi-square. And essentially, you would use this test when your data is nominal. So as opposed to an earlier session where we talked about the univariate t-test, the appropriate test with nominal data is the chi-square. So let's look at a specific example. I'm going to pick on this variable choose. And in our survey, choose was a question that asked the respondents to either choose yes or no, indicating whether or not they would choose to live in the same dwelling again in the future, the same apartment, house, condo, etc. So the first thing I'm going to do is just take a look at my data, try to visualize what's going on. So I'm going to pick a bar chart, and at this point I've already labeled the different response options. So what that means is when I look at the chart, I'm going to get the actual values, the yes or the no, instead of just the numeric codes. So let's take a look at the data here. It looks like most people said that yes, they would. This is good. That means they're good decision makers. They don't have any regrets about the place that they chose to live. So 54 said yes, only 10 said no. So what we want to do is find out if statistically there's a difference in the response between yes and no. One way to think about it is, what would you expect to see if people were equally likely to say yes or no? Well, that would be our null hypothesis. And with 64 possible responses, we would expect to see them roughly evenly distributed, 32 yeses, 32 nos. Right? It looks like that didn't happen here, but statistically we can test to see whether or not we can reject the null hypothesis. Again, the null hypothesis here is simply that people responded yes and no with the same frequency. So for the univariate chi-square, what we're going to do is analyze, and this is a non-parametric test. What that means is, compared to something like a correlation or regression where you end up with a parameter estimate, here there is no parameter estimate. We're just going to get a chi-square that tells us whether or not our actual values or actual frequencies differ significantly from our expected frequencies. So we're going to do analyze, non-parametric test, one sample. So we're going to do analyze, non-parametric test, one sample. So we wanted to automatically compare the observed data to the hypothesized. We'll leave that as is. Next, we're going to select fields. Now it sort of automatically defaults to want to test all of these different fields using the chi-square. We don't want to do that. We want to use custom field assignments. So I'm going to click here. And now I can select my variable and focus on that variable choose. I'm going to go ahead and run this. I'm going to go ahead and run this. And here's what we get. The significance is 0.000. Now, practically speaking, you would never have a zero probability. So what it's done is truncated here. So we could say instead that the p is less than 0.001. That would probably be a more appropriate way to do it. In any case, what this is definitely saying is that we do have statistical significance, meaning that we can reject the null hypothesis. And it happens to be that right now that default level is set at 0.05 in SPSS for the chi-square test. So we can say definitively, not only did it look like there were more yeses than nos, but we can say that actual values, the ratio of yeses to nos, differs significantly from what we would otherwise expect, which is just an equal distribution or equal frequency of yeses and nos.